assume we have function f written in this form, and as you see, the schematic is 2 AND gates and 2 OR gates. And the question is, how can we implement this design using NAND-only gates? One way to do it is to take this function and use De Morgan's law. It says A, B, all bar is equals to A bar plus B bar. And also A or B, all bar is equals to A bar, B bar. You can use this De Morgan's law and put this function in the NAND-only format, which will be this one. The other way is to go ahead and draw the schematic diagram as shown here, and then use the bubble-to-bubble connection to add bubbles and cancel them out to put this AND gates and the OR gates into NAND gates only. Let's try and do that now. So it's easier to transform the AND gate to an AND gate. All we need to do is add a bubble and this becomes an AND. But if we leave it like that, you will be changing the functionality of F. So we want to cancel this effect. So what we do is we cancel the bubble. The same applies here. Add a bubble. This becomes an AND, but you need to cancel it out. How about the OR? Well, we need to use the De Morgan's law. So we want this form. We want A, and A here represents any expression, any input, and B. So this is equals to A bar plus B bar. So this is an OR, which is what we have here. So this means to make it an AND, we have to negate the inputs going to the OR, which means we have to negate these two inputs. Again, we'll have the same problem. If we put the bubbles without canceling them out, we are changing the function, and we do not want that. So that's why we have to add a bubble here and a bubble here. So all these bubbles will cancel as if we didn't do anything. Now this OR became an AND according to De Morgan's law. How about this one? How about this one? We need to do the same. So this here, we'll add a bubble at each input and cancel it out. Okay? So all of this schematic now became NAND only. One thing we need to do is about this bubble here, because it's at the output, so we cannot leave bubbles at the output. This has to be replaced with an actual gate, an actual NAND gate. So this will be an AND gate because this is how we implement the inverter using NAND gate. And how about these? How about these bubbles at the input? they can be left as bubbles because the bubbles at the input side are considered free, which means you can get the effect of negation using switches, and you don't really need to add any inverters here. You don't need to add any hardware to get the zero logic. So this schematic, all of it now is implemented using NAND only gates.